Hook, hook. Most engineers design machines perfectly, but forget one thing: human safety and access. And that mistake can lead to serious accidents near couplings. Today, I'll show you how to design coupling areas correctly. Coupling area is one of the most dangerous zones in rotating equipment. High speed, exposed shafts, frequent maintenance. If design is wrong, safety risk is high. So this topic is critical for GA review, package design, site safety. Slide 2, why it matters. Poor design leads to injury risk, compliance failure, maintenance delays, costly rework. One bad layout can affect the entire life cycle. Slide 3, what is coupling guard? A coupling guard is a protective cover over coupling, shaft ends, keyways, rotating parts. Its job is simple: protect people from rotating hazards. Slide 4, design principles. Good guard design must follow full enclosure, rigid construction, proper ventilation, easy removal. Never weld guards permanently. Maintenance access is critical. Slide 5, clearance requirements. This is where most designs fail. You must provide space for guard removal, 75 to 100 millimeters clearance, alignment tools, maintenance work, and one big mistake: never route piping above coupling. Slide 6, GA review checklist. During GA review, always check: can guard be removed easily? Can bolts be accessed? Is there space for alignment tools? Are both shafts accessible? If not, redesign before construction. Slide 7, ergonomics and safety. Think like a technician. Safe working space, no obstruction in walkway, minimum 600 millimeters from edges, proper lighting, designed for humans, not just machines. Slide 8, standards. Relevant standards include API 610, pump safety, API 686, installation, OSHA, machine guarding. Company standards may be even stricter. Slide 9, real cases. Real problems in field: pump skid, pipe above coupling, compressor, difficult guard removal, turbine, thermal growth issue. These mistakes increase downtime. Slide 10, common mistakes. Avoid these: guard touching coupling, no inspection window, bolt access blocked, welded guards, skid interference. These lead to unsafe conditions. Slide 11, thermal growth. This is a very important concept. Machines expand during operation. If guard is mounted on machine, it can hit. Correct rule: always mount guard on baseplate so clearance remains safe during operation. Slide 12, maintenance view. Think about shutdown. 1, remove guard. 2, inspect coupling. 3, replace parts. 4, reinstall. Good design equals fast maintenance. Bad design equals long downtime. Slide 13, interview questions. If you want to crack interviews, guards prevent contact plus contain failure. Clearance for 75 to 100 millimeters. Mount on baseplate. Ventilation avoids heat buildup. Biggest mistake equals piping near coupling. Answer like this: you stand out. Slide 14, final takeaway. Remember this simple rule: guard protect, clearance, space access, maintain thermal, movement. A safe design balances all four. If you want to become a top engineer, you must design not just for machines, but for people working on them. Like the video. Subscribe for real engineering knowledge. Comment safe if you want real accident case studies. See you in the next one.